Assalamu alaikum. Today we are going to see how to perform the experiment number 1 in CSE251 course. So let me bring up the lab manual first. So it is given on the shared folder. So I bring up the lab manual. So first of all, we need to build this circuit, and after building this circuit in the hardware lab, we measured this VD, that means the voltage across the diode, and the current passing through it, and we also measured the voltage across the resistor, which is known as VR, and the DC voltage source. Now after creating this after building this circuit, we need to plot the VD versus I to find the IV characteristics, which was already discussed in the lab. So first of all, we need to plot the circuit using MATLAB or Excel or any software of your choice, and after that we need to do these tasks. These things were already discussed in the class. So in this video I'm going to show you how to do this same experiment in simulation. That means to answer the question number 5 in the post lab report questions, we need to simulate the circuit in PSpice. So let me fire up PSpice first. So I click on the start button, and if PSpice is installed, if I type SCHE, and the schematic software will come up. So now this is the window of PSpice where we can PSpice schematics where we can build the circuit. So let's click on this binocular icon to get new part, and a window will come. Let's take a DC voltage source by typing VDC. So click here. I click here and place. I click once over here to place the voltage source. Now let's take a diode. So let us type DIODE or just type D, and we take this one D1N4148 diode. I click on place and I place it over here. Now we need a resistor as per the circuit diagram. Over here we need a resistor. So let's bring up the resistor. I press R and the resistor will be here. Then I click place. But in order to rotate it, I press Ctrl R to rotate it. So I need to make it vertical and I click here. Now in order to simulate, PSpice always needs a ground, as you already know. So I type GND and I place an analog earth ground over here, and I place it like this. Now I close this one and I click on the fourth zoom button. Now I will draw the wire. So I click here, and whenever I click, I make a single click, I will have a bend over here. So similarly, I click here and connect it to the resistor. Then I click here and connect it to the ground terminal. And then from the ground, I take it to the negative terminal of the voltage source. We can rename the voltage source as E or VS. So I keep it like E. Then we have the circuit already. Before the simulation, we need to save the circuit. So I click on the save button. Then I type Exp01 demo. I have already built the circuit earlier, so the name is already there, but I'm going to replace it with the same name. So we have the exp01 demo.sch file as our circuit. So now in the lab experiment, actually we have started with 0.1 volt. Then we measured the voltage across the diode and the current passing through this circuit. Then we make it 0.02. Then we do the same thing again, the voltage across the diode and the current that passes through these elements. But in the PSpice, for the repetitive task, we have an option which is analogous to your looping option, which is known as sweep. So before the simulation part, I click on this button to do the analysis setup. So you can also have this option from the analysis menu and the setup option. So here we can have the same option. So I check the DC sweep button and I click on the DC sweep button, and the voltage source is the sweep variable. That means the variable we will vary, and the name of the voltage source will be E. If it was V1, I type V1. Now our voltage source is called E. That's why I put it as E. Now from which value we need to simulate? So let us start from 0.001, and we will end the value at, let's say, 10 volt, and the increment value will be 0.001. So we take as many as 10,000 values for this simulation. So I close everything, I save once again, then I click on this yellow button to simulate the circuit. So if everything is okay, PSpice will show us a probe window. The probe window is already here. So this black window is called the probe window. So before doing anything, let's take the voltage across this diode and see how it is changing. So in the x-axis we have the value of E, we have the value of the voltage source. That means we have the value of E. It is plotted on x-axis, and the y-axis we will take the voltage across the diode. So in order to take the voltage across the diode, we have the diode name as D1. So I click on this trace button, or I can click on this trace menu, then add trace option. It will bring up the same window. If I click over here, or if I click on the trace menu, then click on the add trace button, the same thing will happen. Now on the y-axis variables, these y-axis variables are known as the traces. So we need to add our first trace. So as we have said earlier, that the voltage is actually the voltage across the diode. So diode has two terminals. This is the first terminal of the diode, this is the first terminal of the diode, and this is the second terminal of the diode. So in order to have the voltage across the diode, we need to have voltage for this one minus the voltage for this one. So voltage for the first terminal of the diode minus voltage for the second terminal of the diode. So we do the same thing in the trace window. We take the voltage for the first terminal of the diode, then we type a minus sign from the keyboard, then we click on the second terminal of the diode. If we accidentally click multiple times, so we see that the trace expression will have multiple VD2. So we need to make sure that we do not click multiple times. So I click only once, and we have the trace expression like VD1 colon 1, that means the first terminal of the D1 diode, minus VD1 colon 2, that means the second terminal of the voltage, second terminal of the voltage of the second terminal of the diode. Okay, so I click on OK, and I see that the voltage is actually not increasing that much. So previously it was increasing gradually, but the voltage is kind of fixed after some time. So we see that which is around 0.7 volt or something. So zero point 0.4, zero point 0.5, zero point 0.6, and 0.7 and 8. So we know that for silicon diode, the voltage across the diode is kind of fixed, which is 0.7 theoretically, but practically we see that it is gradually increasing and it is kind of saturated. So it is kind of saturated around voltage 0.7. So voltage across the diode is actually 0.7. Now let us simulate once again, and to do what they have asked us to do. So they have asked us to simulate the circuit. So to plot the first, they told us to they told us to plot VD versus VS, as we have done already. VS is actually known as E for us, and now we will do that ID versus VS. So for ID versus VS, we see that in the x-axis we have the voltage. So we need to change the axis variable. So we go to the plot menu, then click on the axis settings. Then on the x-axis variable, we need to change it. So from the under the x-axis tab, we click on this axis variable option. So in the axis variable option, we can have the current through the diode. So I click on this ID1, or I can take any I value, because this is a series circuit. All the ID, IE, and IR will be the same thing. So but let's take the same diode. So that's why same current that flows through the diode. So I click on this ID1. So we will have the current in the x-axis. So we have ampere in the x-axis. That means we have I in the x-axis. Now on the y-axis we need to have V, but that V will be the voltage across the diode. So as we have shown earlier, we will bring up this voltage D1 minus D2 expression in the trace box to get the voltage across the diode. So this is the voltage across the diode. We will be having this one. But if we want to change it, let's say, let's simulate once again. Let's simulate it once again. So in the x-axis we have V, and in the y-axis we have I. So in the x-axis we have V already. In if we want a I in the y-axis, that means current in the y-axis, I click on this ID1 as an expression. So here we will have the characteristics curve of the diode. So we see that the diode is actually having a knee voltage which is around less than less than 1 volt. So if we have 5 divisions over here, so around zero point 0.5 volt the current is starting, and after some time it is linearly increasing. So diode has an internal resistance. The slope of this straight line will give us the internal resistance of the diode. If you want to have a closer look, then we have to limit the 10 volt to some lower value to get the higher slope of the to see it properly. For example, we can change the sweep variables increment value to the end value. Let's have it up to 5 volt. Then press OK and simulate once again. So we already have voltage in the x-axis. Now we bring up current for the y-axis, ID1, this one. But the thing is, in the x-axis, we have the voltage sources value. But in the x-axis, we need the value of the voltage across the diode. So this diagram is kind of wrong. So that's why we need to change the axis variable. So let's simulate once again. Then go to the plot menu and click on axis settings. In the x-axis, we need to change the axis variable. So in the axis variable, we need to have the voltage across the diode, as we have told you already 2 times. Like the voltage across the diode will be VD1 minus VD2. So now the axis variable will be changed. So here we have the axis variable changed. Now on the y-axis, we need to have the current. So similarly, ID1, I place this one, and we see that the characteristics of the characteristics curve of the diode is over here. So we only have the diode and the current that passes through the diode. We have this one. Now it will give us the internal resistance of the diode. But the previous one we have shown earlier, it will have the internal resistance plus the series resistance we have. So the previous diagram we have shown, it will have the internal resistance of the diode Rd plus R together. But here we have the voltage across the diode only and the current through the diode. So that means it will give us the slope of this straight line will give us the internal resistance of the diode. So if you want to calculate the internal resistance of the diode from this graph, so we click on this button. This button is called the cursor. So we turn on the cursor. So we click on a very upper value over here and press on this button, and it will give us the value of the voltage and current. It's not being shown properly. Let's take another one. Here we have this value, and here we have another value. Since it is not being shown earlier, we can adjust the plot. In the auto range, we have up to 700 millivolts. So we can have one up to 1000 millivolt to see it properly. Now we can see it properly, and we can calculate. The values of the. We can calculate the value of the slope from these three values. For printing, we will not take screenshots because this is not printer friendly. We will click on this print preview button. Oops, sorry, we will have this print preview button. For some reason it's not being shown. Okay, but if you please press on this print preview button, it will show the printer friendly version of the picture. Now let's calculate as I cannot show you now, I'm not wasting time on this, but if we want to calculate the slope for this one, so we will take y2 minus y1 divided by x2 minus x1. So it will give us, sorry, in the y-axis we have current and x-axis we have the voltage. So we will have x2 minus x1 divided by y2 minus y1. This will give us the value of the resistance of the internal resistance of the diode. So as we see from the calculation, I have this 6 point something. I have this 672.573 milli. So 6.2.573 into 10 to the power minus 3 is milli, minus 649.152 milli. So divided by, so this is the value of the axis value. So this is the voltage divided by the current. So 3.9465 milli minus 2.4849 milli. So this gives us the value is around 16 ohm. So the internal resistance of the diode is actually 16 ohm. Let me show you. If I have the x-axis value of the voltage source, then we will have the internal resistance of the diode plus the series resistance. We have 1 kilo ohm over here. So we will have that value. So let us simulate this circuit once again. Now in the x-axis, we do not have the voltage across the diode. We have the voltage sources value. Now on the y-axis, we will take the current passing through the circuit. So now if we take the slope of this one, similarly we turn on the cursor. Let's take a very high value over here. Let's say this one and that one to find the value of the internal resistance. So let me type. So from here we see that the slope is around 1019 ohm. It's around 1019 ohm. So we understand that the internal resistance is around 16 ohm or 19 ohm as per this one. But here it is showing 1019. That means this circuit has an internal resistance of the diode RD plus 1000. So RD is actually in according to our previous calculation it was 16, and according to this circuit, if we place in the x-axis the voltage source instead of the voltage across the diode, we will have the total combined resistance. So to summarize, if we calculate as if we plot the x variable like this, that means in the x-axis we have the voltage source. So we are basically simulating this circuit. We are basically simulating this circuit actually. So this circuit is actually taking the voltage across the voltage source and the current. So which is actually taking the voltage source, taking the voltage across the voltage source. That means we are actually taking the diode and the resistor together. Because if we consider these two as series element and one single element, these two elements are in parallel with this one. So voltage across the voltage source is actually the voltage across the diode and the resistor combinedly. So if we take it like this, in the x-axis we have the V source, just like this we have the V source VE, the source voltage. The slope will give us the internal resistance plus the 1 kilo ohm resistance we have in series with it. So the internal resistance of the diode is this one, and the 1 kilo ohm resistor like this. So we need to, in order to calculate the internal resistance of the diode, we need to subtract this value. This is what we have done in Python. So we in the next second calculation we see that the value is around 1019. So the internal resistance from this circuit, from this simulation, is around 19 ohm, because 1019 minus 1000 will be 19 ohm. But if we take this one, like instead of the previous one, like instead of taking the voltage source as the x-axis variable, we took the VD11 minus VD12. That means the voltage across the diode as the x-axis variable. We will have only this internal resistance of the diode in consideration. So at that time, the slope will give us the x2 minus x1 and y2 minus y1, which will be 1 by the slope. So it will give us the internal resistance of the diode only. So it will not give you the series resistance, because we are taking this part only. We are taking this part. So since the current is same for everyone, ID in the y-axis and in the x-axis we have the voltage across the diode, we will have the internal resistance of the diode like this. So just to show you, to have the internal resistance of the diode only, we need to simulate the circuit, and we need to change the axis variable first. So after the simulation, by default it will show the sweep variable in the x-axis, but we need to change the sweep variable. So click on the axis settings. Under the x-axis we click on the axis variable to change it. Now we take the VD11 minus VD12 to have the axis variable changed to the voltage across the diode. Now we have the voltage across the diode. We, in order to adjust the plot, we can also click on axis settings and we change the range to 700 millivolt to, let's say, 1000 millivolt. That means up to 1 volt. Now we take the trace expression as the current ID1. Okay, so we have the internal resistance of the diode from this graph only. It will not require you to subtract the value of the external series resistance we have with the diode. So from this figure we will have this one. So x2 minus x1 divided by y2 minus y1 give us the 1 by slope of the diode. It will give us the internal resistance of the diode only. As we have seen earlier, we did this calculation earlier, and we see that the internal resistance is around 16 ohm. And if we do not change the axis variable like I have done right now, if we do not change it, then we will have the internal resistance plus the additional external resistance we have. If it is 500 ohm, then we need to subtract 500 ohm from it. So this is what this lab sheet was asking us to do. That means this lab sheet told us to ID versus VS, but I have told you to do additional thing, which is to ID versus VD as well. So VD versus we need to actually plot three graphs. So which is ID versus VS, ID versus VD, which is this one, and VD versus VS, which I have shown you at the very first time. So thank you very much. If you have any questions, please feel free to ask, and we will see you in the lab. But before finishing, let me show you one final thing. So in the lab, we will need to take readings for this one, like vary the voltage sources value from zero point 0.1, zero point 0.2, zero point 0.3, like this given values, and calculate and measure the values for the voltage across the diode. And we see that the voltage across the diode is kind of saturated around 0.7 volt. It is not increasing that much. So this phenomena we have seen earlier, like instead of having this trace, but instead of having this I as the trace, if we have the voltage source and the voltage across the diode, we will see that the voltage is, no, not this one, sorry. Let me simulate again. Uh, VD1 minus VD2. So we see that the voltage is kind of saturated around zero point 0.7 volt, which supports our lab sheet value. Also, we see that the diode needs to be turned on after some time, because for the first few values, we will not have any current passing through it. That's why the voltage across the resistor is zero, and the voltage and the current is also zero. Now, if you want to plot it, you need to be careful that which variable we are plotting in the x-axis, because in the Excel, if you want this V in or any other software, if you have VD as the diode voltage and ID as the current, so you need to have this column as the x-axis and this column at the y-axis. So I have separated this over here to have this graph. But if you have this value versus that value, let me take a different sheet. So take the voltage source and the current that is passing through this one. Okay, so if we insert a new plot over here, so click on this insert menu and this option, we will see that we have kind of a straight line. So this straight line will have the slope which corresponds to the internal resistance plus the additional extra resistance we have in series with the diode. So the combined effect will be
এখন
there
সময়
for this kind
রাত
of graph. So
11টা
if you take the
15 মিনিট
voltage across the diode only instead of the voltage source, so we will see that we have this graph over here. But if you have it like this earlier, we will have the combined effect. But if you have the voltage across the diode, you will have this one only. So this is what I was trying to discuss and show it with you. And we also have lots of other calculations as well. The internal resistance, instead of the internal resistance, we have the reverse saturation current, the diode parameter N, and some other parameters, reverse saturation current, which will be discussed in the class. And this file is shared with you already in the shared folder. So if you want to have access to it, you can have it. It is given in the shared folder if I'm not wrong. So this folder is already shared with you, and in the data for lab experiment 1 you have this excel file which is already shared with you. So I hope all the confusions are clear now. Instead of doing it blindly, try to do it by understanding first, then do it by yourself, so that you have a clear understanding of the experiment. This part will be required for your class test and the midterm exam, as well as for the lab exam as well. So thank you very much for your patience. Assalamu alaikum.